In commercial and industrial electrical design, the likelihood of encountering a non-fused disconnect is minimal. The National Electrical Code, or NEC, mandates overcurrent protection for disconnects. This regulation means that nearly all disconnects must be fused or protected by a circuit breaker. The NEC specifically requires overcurrent protection for service disconnects, main disconnects, and branch circuit disconnects. Fusing disconnects offers several crucial benefits. Firstly, overcurrent protection. Fuses or circuit breakers safeguard wiring and equipment downstream from the disconnect against damage from excessive current flow. Secondly, isolation. Fuses or circuit breakers allow safe opening of the disconnect under load, ensuring circuit de-energization for maintenance or repairs. Thirdly, NEC compliance. The NEC mandates overcurrent protection for all disconnects. Typical applications for fused disconnects include service entrance panels, main distribution panels, branch panels, motor control panels, lighting circuits, and power circuits. While theoretically possible to have a non-fused disconnect in limited scenarios like control circuits, it's highly unlikely in commercial or industrial electrical design. All disconnects in these applications must be fused or circuit breaker protected to ensure safety and NEC compliance. The primary reason for using fused disconnects revolves around safety and code adherence. Fuses and circuit breakers act as protective devices, interrupting the flow of electricity when the current exceeds a safe level. This protects equipment and prevents electrical fires. Without overcurrent protection, a fault current could cause significant damage and pose a serious safety hazard. The National Electrical Code, or NEC, sets the standard for safe electrical installations. Its requirements for overcurrent protection are designed to minimize risks and ensure the reliability of electrical systems. While the NEC provides flexibility in certain areas, the requirement for overcurrent protection on disconnects is strictly enforced in most commercial and industrial settings. To further clarify the role of overcurrent protection, consider a scenario where a motor winding fails, causing a short circuit. Without a fuse or circuit breaker, the fault current would continue to flow, potentially damaging the motor, connected wiring, and other equipment. The heat generated by the fault current could also ignite nearby materials, leading to a fire. A correctly sized fuse or circuit breaker would quickly interrupt the current, preventing these consequences. Disconnects serve as a means to isolate electrical circuits for maintenance, repair, or troubleshooting. When a disconnect is opened, it creates an air gap, effectively cutting off the power supply to the downstream equipment. However, if the disconnect is opened while carrying a high current, it can create an arc flash, posing a severe safety risk to personnel. Fuses or circuit breakers mitigate this risk by interrupting the current flow before the disconnect is opened. This ensures that the disconnect can be safely operated without the danger of an arc flash. In some specific situations, it might seem permissible to use a non-fused disconnect. However, even in these cases, it's generally advisable to incorporate overcurrent protection for safety and code compliance. For example, in a control circuit with limited current, a non-fused disconnect might appear adequate. However, adding a small fuse or circuit breaker provides an extra layer of protection against unforeseen faults. The cost of overcurrent protection is typically minimal compared to the potential cost of equipment damage, injuries, or legal liabilities resulting from an electrical incident. When selecting fuses or circuit breakers for disconnects, it is essential to choose the correct size and type. The overcurrent protection device should be rated to handle the expected load current of the circuit while also providing adequate protection against fault currents. The NEC provides detailed guidelines for selecting overcurrent protection devices based on the type of equipment being protected, the conductor size, and other factors. Consulting with a qualified electrical engineer or electrician is crucial to ensure that the correct overcurrent protection devices are selected. The location of the disconnect is another important consideration. Disconnects should be readily accessible and located in a safe and convenient location. The NEC specifies requirements for the accessibility and working space around electrical equipment, including disconnects. In some cases, it may be necessary to install multiple disconnects to provide adequate isolation for different parts of a system. For example, a motor control panel might have separate disconnects for the incoming power supply, the motor starter, and the control circuit. The selection and installation of disconnects should always be performed by qualified personnel who are familiar with the NEC and other applicable codes and standards. Electrical work can be dangerous, and it is essential to take all necessary precautions to prevent accidents. This includes wearing appropriate personal protective equipment, using properly insulated tools, and following lockout/tagout procedures to ensure that circuits are de-energized before working on them. While the use of non-fused disconnects is rare in commercial and industrial settings, it is important to understand the reasons why they are generally not permitted. By adhering to the NEC requirements for overcurrent protection, you can help ensure the safety and reliability of electrical systems. The vast majority of disconnects you encounter will indeed be fused, underscoring the critical role of overcurrent protection in electrical safety. Consider a large industrial facility with numerous motors, lighting circuits, and other electrical loads. Each of these loads requires a disconnect for maintenance and safety purposes. If even one of these disconnects lack proper overcurrent protection, it could create a weak link in the electrical system, increasing the risk of a fault or a fire. By consistently using fused disconnects throughout the facility, the overall safety and reliability of the electrical system is greatly enhanced. In addition to protecting equipment and preventing fires, fused disconnects can also improve the uptime of electrical systems. When a fault occurs, a fuse or circuit breaker will quickly isolate the affected circuit, preventing the fault from spreading to other parts of the system. This can minimize downtime and reduce the cost of repairs. In contrast, if a non-fused disconnect is used, a fault could cause widespread damage, potentially shutting down the entire facility. The importance of using fused disconnects extends beyond simply meeting code requirements. It reflects a commitment to safety, reliability, and responsible electrical design. Electrical designers and drafters play a crucial role in ensuring that electrical systems are properly designed and installed. By understanding the principles of overcurrent protection and the requirements of the NEC, they can contribute to creating safer and more reliable electrical systems. In summary, while non-fused disconnects may have limited applications in specific control circuits, they are rarely used in commercial and industrial electrical design due to the paramount importance of overcurrent protection, NEC compliance, and the overall safety of electrical systems. The consistent use of fused disconnects is a fundamental practice that helps to prevent equipment damage, electrical fires, and personal injuries. Remember that safety should always be the top priority in electrical design and installation. Adhering to the NEC and other applicable codes and standards is essential for ensuring the safety and reliability of electrical systems. When in doubt, consult with a qualified electrical engineer or electrician to ensure that the correct disconnects and overcurrent protection devices are selected for your specific application. It is also important to regularly inspect and maintain electrical systems to ensure that disconnects and overcurrent protection devices are functioning properly. This includes checking for loose connections, damaged wiring, and signs of overheating. By taking a proactive approach to electrical safety, you can help prevent accidents and ensure the long-term reliability of electrical systems. Always prioritize safety, consult with qualified professionals when needed, and stay informed about the latest codes and standards. This proactive approach ensures the integrity and safety of electrical installations in commercial and industrial environments. Overcurrent protection devices such as fuses and circuit breakers play a vital role in preventing electrical hazards. When the current in a circuit exceeds the safe limit, these devices automatically interrupt the flow of electricity, preventing damage to equipment and reducing the risk of electrical fires. Fuses are single-use devices that must be replaced after they have been blown. Circuit breakers, on the other hand, can be reset after they have tripped. Both fuses and circuit breakers are available in a variety of sizes and types to accommodate different applications. The selection of the appropriate overcurrent protection device depends on the specific characteristics of the circuit being protected, including the voltage, current, and type of load. It is important to consult with a qualified electrical engineer or electrician to ensure that the correct overcurrent protection device is selected. Proper installation of disconnects and overcurrent protection devices is also crucial for ensuring safety and reliability. Disconnects should be installed in a readily accessible location and should be clearly labeled to indicate the circuit they serve. Overcurrent protection devices should be installed in a panel board or enclosure that is rated for the environment in which it is located. All electrical connections should be made in accordance with the NEC and other applicable codes and standards. Regular inspection and maintenance of electrical systems are essential for ensuring that disconnects and overcurrent protection devices are functioning properly. Disconnects should be checked for signs of damage or corrosion and should be operated periodically to ensure that they are functioning smoothly. Overcurrent protection devices should be tested periodically to ensure that they are tripping or blowing at the correct current level. Any problems that are identified during inspection or testing should be corrected immediately. Electrical safety is a shared responsibility. Everyone who works with or around electrical equipment should be aware of the potential hazards and should take steps to prevent accidents. This includes following safe work practices, wearing appropriate personal protective equipment, and reporting any electrical hazards to the appropriate authorities. By working together, we can create a safer environment for everyone. The NEC serves as a comprehensive guide for electrical installations, encompassing rules for wiring methods, overcurrent protection, grounding, and equipment installation. It's regularly updated to reflect new technologies and best practices, ensuring the highest level of safety. Staying informed about the latest edition of the NEC is crucial for anyone involved in electrical design, installation, or maintenance. Understanding and adhering to NEC requirements helps minimize electrical hazards and ensures that electrical systems operate safely and reliably. In practical applications, fuse disconnects are integral to various systems. For instance, in heating, ventilation, and air conditioning, or HVAC, systems, fuse disconnects are used to isolate the equipment for maintenance and repairs, ensuring that technicians can safely work on the units without risk of electrical shock. Similarly, in manufacturing facilities, fuse disconnects are essential for isolating machinery and equipment for servicing, preventing accidental startup and protecting workers. The proper selection of fuses for disconnects is critical to ensuring the safety and reliability of electrical systems. Fuses are designed to protect electrical circuits from overcurrent conditions such as short circuits and overloads. When selecting fuses, it is important to consider the ampacity of the circuit, the type of load being served, and the interrupting rating of the fuse. The ampacity of the circuit is the maximum amount of current that the circuit is designed to carry. The fuse should be rated to protect the circuit from overcurrent conditions without causing nuisance tripping. The type of load being served also affects the selection of the fuse. For example, motor circuits require fuses that are specifically designed to handle the high inrush currents that occur when motors start. The interrupting rating of the fuse is the maximum amount of fault current that the fuse can safely interrupt. Fuses with higher interrupting ratings are required for circuits that are more likely to experience high fault currents. The NEC provides detailed guidelines for selecting fuses for various applications. These guidelines should be followed carefully to ensure that the electrical system is properly protected. Proper installation of fuse disconnects is also essential for ensuring safety and reliability. Fuse disconnects should be installed in accordance with the manufacturer's instructions and all applicable codes and standards. The disconnect should be mounted in a readily accessible location and should be clearly labeled to indicate the circuit that it serves. All electrical connections should be made securely and should be properly insulated. Regular inspection and maintenance of fuse disconnects are also important for ensuring their continued safe and reliable operation. Fuses should be inspected periodically for signs of damage or deterioration. Disconnects should be operated periodically to ensure that they are functioning properly. Any problems that are identified during inspection or maintenance should be corrected immediately. In conclusion, fuse disconnects are an essential component of safe and reliable electrical systems. They provide overcurrent protection, isolate equipment for maintenance and repairs, and prevent accidental startup. Proper selection, installation, and maintenance of fuse disconnects are crucial for ensuring the safety of workers and the reliable operation of electrical equipment. While non-fused disconnects may seem like a cost-effective alternative in some applications, the potential risks associated with their use far outweigh any potential cost savings. In general, it is always best to err on the side of caution and to use fused disconnects whenever possible. In areas where electrical work is performed, safety protocols should be clearly displayed and readily available to all personnel. Regular safety training should be provided to ensure that workers are aware of the potential hazards and how to avoid them. Emergency contact information should also be readily available in case of an accident. By taking these steps, we can create a safer environment for everyone who works with or around electrical equipment. In the vast landscape of electrical safety, every precaution and safety measure is a testament to our commitment to protect lives and prevent accidents. From the design phase to the installation and maintenance of electrical systems, a focus on safety is paramount. Let us remember that electricity is a powerful force that demands respect and caution. By adhering to safety guidelines, we can harness its energy while minimizing the risks. In the realm of electrical design, a meticulous approach to component selection is crucial. Choosing the appropriate fuses, circuit breakers, and disconnects ensures that the electrical system can withstand the demands of its intended use while maintaining a high level of safety. Factors such as voltage ratings, current ratings, and interrupting capacities must be carefully considered to prevent overloads, short circuits, and other electrical hazards. Electrical installation should be performed by qualified and experienced professionals who are well versed in the NEC and other relevant codes and standards. Proper wiring techniques, grounding procedures, and equipment installation methods are essential for preventing electrical shocks, fires, and other accidents. Regular inspections and maintenance are crucial for ensuring the continued safe operation of electrical systems. Identifying and correcting potential problems before they escalate can prevent costly repairs and, more importantly, protect lives. These inspections should include checking for loose connections, damaged wiring, and signs of overheating.